Tensors are a fundamental data structure in PyTorch optimized for machine learning and for computational operations involving numerical data. If you look at a lot of PyTorch code on GitHub or other places online, it looks like they are just like NumPy arrays. But actually, tensors can be loaded and executed on a GPU as opposed to NumPy, which is usually on CPU. In PyTorch also, we commonly use tensors as inputs and outputs to a machine learning model, or you can also use them to represent the weights of your model. Here I have a Python list 1, 2, 3. I'm calling it vec. And in here, after importing the PyTorch framework, I use the tensor methods. You can think of it like a factory method, and I pass it my data here so that tvec becomes a tensor. So let's look at what happens if I set this tvec and then I print the shape. I get 3. And that is a one-dimensional tensor. Here is another example. I have a 2-dimensional array. So I have 3 columns and 2 rows here. Again, I use the tensor method. I pass in my matrix. I store it in the variable called tmat. And here, when I print the shape, I have torch.size, and it's 2 rows, 3 columns. So it's y value first and then x value, or the height and then the width. This is another example to show that you can create tensors from NumPy arrays. Here, npmat is a NumPy array, and here I create a tensor out of it. When I print both of them, we get the same value. Basically, it's the 2D array, but here with the tensor, it is wrapped inside of this tensor. When I print the shape, I get 2, 3 in a tuple for the NumPy array, and then I get torch.size 2, 3 for my tensor.